Hello everyone, we're students of Tver State Medical University and today we're gonna tell you about drug-loaded implants. Nowadays, there's a great variety of different means of drug delivery, but they're not free of drawbacks. Researchers are trying to create a flawless system to deliver drugs without any efficiency loss or harmful effects. That's how an idea of a drug-loaded implant, an innovative product that promises to make a significant contribution in the future of pharmacy, was created. What is a drug-loaded implant? As the name suggests, it is an implant filled with medicine that is surgically implanted right into the damaged tissue or organ, not only providing mechanical support, just like an ordinary implant, but also releasing a drug at the site of the implantation in order to improve the implant's effectiveness and to reduce side effects of treatment. Drug-loaded implants demonstrate a number of advantages over traditional drug delivery methods. They release a precise dosage of a drug, improve patient compliance, minimize potential side effects, and enhance the quality of life. These systems are of different forms and sizes, which depends on their application. So let's find out what kinds of drug-loaded systems have been created up to this point and how they are used.
So let's start with a group of drug-loaded implants for cardiovascular diseases. It is widely acknowledged that cardiovascular diseases continue to be the leading cause of death globally. Medical implants that release drugs into the body do more than just provide mechanical support. They also have a therapeutic role. Primarily, it is achieved through the controlled release of active pharmaceutical ingredient at the implementation site. This group of implants includes, for example, drug-eluting stents. These implants are put into troubled vessel with atherosclerosis. They reinforce vessel and normalize bloodstream. They are used to maintain the patency of blood vessels and release drug into nearby tissue. Another member of this group is cardiac patch. It is a flat device which is put on damaged part of the heart, where it is able to effectively regenerate heart tissue in patients undergoing treatment for cardiac illness. Drug-eluting cardiac patches can mimic the natural process of heart tissue regeneration. But cardiovascular diseases are not the only application area. Drug-loaded implants have attracted considerable attention in cancer treatment due to the precise delivery of drugs into cancer tissues. Drug-loaded implants have several advantages, including a reduction in frequency of drug administration and minimal systemic toxicity. Also, there are other fields of use of drug-loaded implants. They are used in dentistry and surgery to prevent an infection associated with implants. In this case, implants are loaded with antibiotics. Drug-loaded implants also can be filled with hormones for long-term treatment, but such cases are rare yet.
The utilization of drug-eluting implants represents an extremely promising direction in medicine, but despite all their significant advantages, such systems have a number of serious drawbacks that need to be overcome. Firstly, this includes the necessity to consider the anatomical peculiarities of each patient. This leads to technological complexity in implant manufacturing and the impossibility of their serial production, as well as prolonged fabrication times. Secondly, there is a high cost associated with an each implant, severely limiting their dissemination in modern medical practice. But progress doesn't stand still, and there are ongoing developments in innovative implant manufacturing methods using additive technologies, particularly 3D printing. 3D printing, also known as additive manufacturing, involves generating the geometry of three-dimensional objects by depositing, bending, or fusing materials layer by layer. So, the production of almost any shape with a high degree of complexity becomes conceivable. These shapes cannot be achieved by common non-additive manufacturing methods, making 3D printing a great opportunity for the growing demand of personalized medicine. However, this technology has significant drawbacks. Firstly, the need of post-processing of printed products. Secondly, requirements for personnel who must be familiar with the capabilities of equipment such as 3D printers. And the last, potential toxicity of many popular polymers. Thus, despite these drawbacks, 3D printing solves the issue of high product cost and significantly accelerates the mass application of implants in medical practice. Today, we've told you about drug-eluting implants, their application in modern therapeutic practice, and the further prospects of this technology. We hope you found this information interesting and useful.